In this lesson, we're going to be learning about oxidation and reduction reaction, also called redox reaction. We're going to study oxidation, but you must have known oxidation as gain of oxygen or loss of hydrogen, and reduction as loss of oxygen or gain of hydrogen. But in this lesson, we'll be studying oxidation and reduction reaction under the concept of electron transfer. But if this is the first time on this channel, please click on the subscribe button, like, comment, and share. Let's continue. Now, let's understand the concept of oxidation and reduction. We're going to use a simple mnemonic called OI-RIG. OI stands for oxidation is loss of electron, while RIG stands for reduction is gain of electron. I repeat, OI stands for oxidation is loss of electron, RIG stands for reduction is what? Gain of electron. Now, when you have potassium ion and chlorine ion, potassium will donate electron or will lose electron, and chlorine will gain the electron. By the loss of one electron, potassium will become positively charged, while chlorine become negatively charged. So the loss of electron, potassium become oxidized, while chlorine gains an electron and becomes reduced, and they form potassium chloride. Let's look at another example. If sodium reacts with hydrogen, sodium will lose an electron, while hydrogen will gain an electron. Sodium will become positively charged by becoming 1+, while hydrogen will become negatively charged and becomes -1. Sodium has lost an electron, so it is oxidized. Hydrogen has gained an electron, so it is reduced. Let's look at another example. If calcium reacts with chlorine, calcium will lose 2 electrons. And because a chlorine atom can only accept 1 electron, 2 chlorine atoms will pair up to accommodate the 2 electrons. So each chlorine atom will take 1 of the electrons contributed by calcium. So calcium will become positively charged and become +2, while each of the chlorine atom will become negatively charged and become -1 each. Calcium has lost 2 electrons, so it is oxidized, while each chlorine atom has gained an electron, so they are reduced, and they will end up forming calcium chloride as a compound. So on the whole, potassium, sodium, and calcium have lost electron and they are oxidized, while chlorine and hydrogen has gained electron and they are what? Reduced. Hold it at the back of your mind as a mnemonic. OI-RIG. OI is oxidation is loss of electron, while RIG stand for reduction is what? Gain of electron. You must know this. RIG is what? Reduction is what? Gain of electron. Why OI? Okay, let's look at easy trick for understanding oxidation and reduction. Now, when calcium goes into reaction, it forms an ion +2 by losing what? 2 electrons. Calcium will go into reaction by losing 2 electrons and become what? Calcium 2+, that is positively charged, 2+. Chlorine in reaction we gain an electron to become negatively charged, that is -1, by what? Gaining 1 electron. So generally, metals loses electrons, while non-metals those what? Gain electrons because of the electronegativity. Metal lose because of electropositivity. Now, the oxidation state of calcium has changed from 0 to +2, while that of chlorine has changed from 0 to -1. This change from 0 to +2 is called change in oxidation state. Equally, change from 0 to -1 is also referred to as what? Change in oxidation state. We have a simple mnemonic that will help us remember. We have INO and DO. INO means increasing oxidation number is oxidation, while DO means decreasing oxidation number is reduction. Increasing oxidation number is oxidation, decreasing oxidation number is what? Reduction. So from 0 to 2 is increase, that is oxidation, while from 0 to -1 is reduction. If it's the first time on the channel, before we proceed, hit the subscribe button, and if you're on Facebook or TikTok, hit the follow button so that we can continue. This is School of Chemistry. Let's continue. Now note, before we proceed, you have to know this. INO means increasing oxidation number is oxidation. DO means decreasing oxidation number is what? Reduction. Let's look at certain rules in calculating the oxidation number of elements. Now, elements in their free state have an oxidation number of 0, such as sodium, chlorine in their free state have an oxidation number of 0. Oxidation number of ions is the same as the charge of the ion. So sodium plus has oxidation state of +1, chlorine minus oxidation number of -1, and oxygen 2 minus oxidation state of -2. Sum of oxidation number of elements in a compound is 0. For example, CaCO3. Oxidation state of Ca plus that of C plus 3 oxygen atom will be equals to 0. So we have +2 being oxidation state of calcium plus carbon plus 3 into -2, which is the oxidation state of oxygen, equals to 0. So +2 plus C minus 6 will be equals to 0. So +2 plus C minus 6 will be equals to 0. Collect like terms, I have C minus 4 will be equals to 0. And the oxidation state of carbon will be equals to +4. And that's how to calculate oxidation number of element with variable oxidation state. For example, we have the reaction S plus O2 give you SO2. In free state, the oxidation state of S is 0. That of oxygen is what? 0. Now, to get that of sulfur in O2, we say S plus 2 atoms of oxygen is equals to 0. Oxidation state of oxygen is -2. That means S plus 2 into -2 is equals to 0. And S will be equals to 4. So the oxidation state of sulfur is +4, while that of oxygen is -2. So sulfur has a change of oxidation from 0 to +4, which is increase. That is what? Oxidation. Now, oxygen has a change of oxidation from 0 to -2, which is a decrease in oxidation number. That is what? Reduction. So these two are referred to as what? Redox reaction. That is what? A complementary reaction, reduction and oxidation reaction. Let's look at H2 reacting with F2 to form 2HF. In free state, the oxidation number of H is 0, that of F is 0. While in combined state, we have that of hydrogen is +1, that of F is -1. So from 0 to +1 is increase, that is oxidation, while from 0 to -1 is decrease, that is reduction, and this too is a redox reaction. Let's look at N2 plus H2 to form NH3. In free state, nitrogen has oxidation state of 0 and hydrogen oxidation state of 0. So to get the oxidation state of nitrogen NH3, we say N plus 3 hydrogen equals to 0. Hydrogen has oxidation state of +1. So N plus 3 into 1 will be equals to 0. So N plus 3 will be equals to 0, and N will be equals to -3. So the oxidation state of nitrogen is -3, while that of oxygen is +3. So we say from 0 to -3 is reduction, while from 0 to +2 is increase, and that is what? Oxidation. Now, let's look at this. When water decomposes, these decomposition reactions, to form H2 and O2. H2 and O2 are in their free state, so we have oxidation state of H is 0 and that of O is 0. And for hydrogen, we know that 2H plus O will be equals to 0. 2 into -2, which is the oxidation state of oxygen, will be equals to 0. 2 minus 2 will be equals to 0. So oxygen is -2 and hydrogen is +1. So from +1 for hydrogen to 0 is decrease in oxidation number, and that is reduction. From -2 to 0 in oxygen is increase in oxidation number, and that is what? Oxidation. Let's look at that for calcium carbonate forming CaO plus what? CO2. We have to calculate the oxidation number for each of the elements in their variable states. For CO2, we have C plus 2O is equals to 0. The oxidation state of oxygen is -2. So C plus 2 into -2 is equals to 0. So C will be equals to -4. So the oxidation state of carbon in CO2 is +4. And that of oxygen is -2. Let's look at CaO. In CaO, Ca plus O will be equals to 0. It implies that C minus 2, because the density of oxygen is minus 2, is equals to 0. So Ca will be equals to what? 2. If you take 2 to the other side. So it implies that the oxidation state of calcium in CaO is plus 2 and that of oxygen is minus 2. In calcium carbonate, it implies that Ca plus C plus 3O is equals to 0. Oxidation state of calcium is 2. That of oxygen is minus 2. That means 2 plus C plus 3 into minus 2 is equals to 0. Open bracket, 2 plus C minus 6 is equals to 0. Collect like term. C plus 2 minus 6 will be equals to 0. C minus 4 will be equals to 0. And C will be equals to plus 4. That means that in calcium carbonate, calcium has an oxidation state of oxygen has an oxidation of minus 2, carbon plus 4, and calcium plus 2. Let's look at the change in oxidation state. Calcium has plus 2 changing to plus 2. That means there is no change in oxidation state. Carbon from plus 4 to plus 1, no change in oxidation state. Oxygen from minus 2 to minus 2, there is no change in oxidation. Therefore, this is not a redox reaction. You understand? Because there is no change in oxidation number. Now, if it's your first time on this channel, School of Chemistry, please click on the subscribe button. Subscribe, like, share, and comment. Thank you and welcome for more detailed videos. Now let's study oxidizing and reducing agents. Formerly in our previous lecture, we have looked at the mnemonic INO, which means increase in oxidation is what? Increase in oxidation number is oxidation. And DO, which stands for decreasing oxidation number, is what? Reduction. So when potassium loses an electron, it becomes positive, it forms a positive ion. But before we continue, if it's the first time on this channel, School of Chemistry, please click on the subscribe button or the follow button depending on where you are. Now, elements in their fundamental state have an oxidation state of 0. So potassium has an oxidation state of 0 and potassium ion plus 1. A change of 0 to 1 is what? Increasing oxidation number. So that is what? Oxidation. Now the electron lost by potassium will be gained by chlorine to form chlorine ion. Elements in the fundamental state has an oxidation state of 0. So chlorine will have an oxidation state of 0 and chlorine ion minus 1. A change of state from 0 to minus 1 is decreasing oxidation number. And that will be what? Reduction. Are you following? Now, potassium has what? Lost an electron, while chlorine gains an electron. So we say potassium is oxidized, because oxidation is loss of electron, while chlorine is reduced, because reduction is what? Gain of what? Electron. Now, it is obvious that potassium that has been oxidized is oxidized by something, and that is chlorine. While chlorine that is reduced by something, because they are complementary reaction, that is what? Potassium. That implies that chlorine that is reduced by potassium means that potassium is the reducing agent, while chlorine that has oxidized potassium implies that chlorine is an oxidizing agent. You follow it? So you should know the difference between oxidizing and reducing agents. Examples of oxidizing and reducing agent. When chlorine reacts with oxygen to form CO2, we know that elements in their fundamental state have an oxidation state of 0. So carbon has an oxidation state of 0 and oxygen has an oxidation state of 0. But we need to know the oxidation state of carbon in CO2. That means carbon plus 2O equals to 0, because oxidation state of elements in a compound equals to 0. Oxidation of oxygen is minus 2. That means carbon plus 2 into minus 2 is equals to 0. That means carbon minus 4 is equals to 0. Make carbon the cellular formula, and carbon will be equals to what? Positive 4. That means that the oxidation of carbon in CO2 is plus 4, while that of oxygen is minus 2. Now, looking at the change in oxidation number, carbon has a change of oxidation from 0 to plus 1, that is increase and is oxidation, while oxygen from 0 to minus 2 is decreasing oxidation number, that is what? reduction from our definition. I follow. Now, because carbon is oxidized by oxygen and oxygen is reduced by what? Carbon. Now we can say that oxygen that has oxidized carbon is the oxidizing agent, while carbon that have reduced oxygen is the reducing agent. It's as simple as that. You must get it. So whatever it is reduced is the oxidizing agent, whatever that is oxidized is what? The what? Reducing agent. Let's look at the reaction between hydrogen and what? Oxygen. Hydrogen will react with oxygen to form water. Elements in the elemental state have an oxidation state of 0. So hydrogen has an oxidation state of 0 and oxygen an oxidation state of what? 0. So to get the oxidation state of hydrogen in water is going to be 2 atoms of hydrogen plus oxygen equals to 0. 2 hydrogen minus 2 equals to 0. So that if you collect like terms and divide both sides by 2, have hydrogen equals to plus 1. So oxidation state of hydrogen in water is what? Plus 1, while that of hydrogen is minus 2. Let's look at the change in oxidation number so that we can know our oxidation and reduction. Hydrogen have changed from 0 to what? Plus 1. That is increasing oxidation number, and that is what? Oxidation. Oxygen have changed from 0 to minus 2. That is decreasing oxidation number, and that is what? Reduction. This implies that hydrogen is oxidized by what? Oxygen, while oxygen is reduced by what? Hydrogen. That means hydrogen is the reducing agent because it has reduced oxygen, and oxygen is the oxidizing agent because it has what? Oxidized hydrogen. So the reduction material is the oxidizing agent, while the reducing material, oxidation material, is what? The reducing agent. If it's your first time on the channel, do not forget to subscribe, like, share, and comment. Classwork. Identify the oxidizing and reducing agent in the equation. Zinc plus sulfur forms what? Zinc sulfide. Leave your answer in the comment section. Like. Alright, let me teach you balancing of redox reactions. First, we're going to start by calculating oxidation number of elements with variable oxidation state. For example, Cr2 in Cr2O72 minus and SO2, we're going to look for the elements Cr2 and S. But first, know that the oxidation number of oxygen in every element in every compound is minus 2. So we're calculating the oxidation number of chromium and oxidation number of sulfur. They have variable oxidation state. Now, in Cr2O72 minus, 2 atoms of chromium plus 7 atoms of oxygen have a cumulative charge of minus 2. Now, oxygen have an oxidation state of minus 2, so 2 chromium plus 7 into minus 2 will be equals to minus 2. Open bracket, 2 chromium minus 14 is equals to 2. That means 2 chromium collect like 10 will be equals to minus 2 plus 14. That means that 2 chromium is equals to 12. Divide both sides by 2. You have chromium equals to 12 divided by 2. And chromium will be equals to 6, meaning that it has an oxidation state of plus 6 in Cr2O72 minus. Now in SO2, the sum of oxidation number of elements in a compound equals to 0. That means sulfur plus 2 atoms of oxygen equals to 0. Oxidation number of oxygen is minus 2. That means sulfur plus 2 into minus 2 is equals to 0. Open bracket. Sulfur minus 4 is equals to 0. That implies that sulfur has an oxidation state of 4 because it's equals to 4. You get it. That is how to calculate oxidation number. Meanwhile, if in your first time on the channel School of Chemistry, please click on the subscribe button before we continue. Alright, let's go into balancing redox reaction proper. That is balancing of oxidation reduction reactions in acidic medium. First, we are going to find the oxidation number of element with variable oxidation state, and then we're going to balance the oxygen atom. We are using the ionic method. Now, in the reaction, MnO4 minus plus ion 2 plus, that is Fe2 plus, to form the manganate ion M2 plus ion 3 ion, that is Fe3 plus. Let's calculate the oxidation number of manganate or manganese in MnO4 plus. So it's going to be Mn plus 4O is equals to minus 1, which is the charge of both of them. That means Mn plus 4 into minus 2, where minus 2 is the oxidation state of oxygen, is equals to minus 1. And Mn will be equals to what? 7. That implies that in MnO4 minus, the oxidation state of manganese is +7, while in ion 2, the oxidation state of iron is +2, in Mn2 plus, the oxidation is +2, and in Fe3 plus, oxidation is +3. That means Mn has changed from +7 to +2, and Fe2 plus has changed from +2 to +3. Let's write the half equations. From +7 to +2 of MnO4 to Mn2 plus, it has gained 5 electrons. That is MnO4 minus plus 5e from Mn2 plus. And because there is a decrease in oxidation number, that is reduction. Fe2 plus lost 1 electron to form Fe3 plus. Because there is an increase in oxidation number from +2 to +3, that is what? Enol, that is oxidation. Now, to balance the ions, we multiply the reduction process by the number of electrons in the oxidation process, which is 1, and we multiply the oxidation process by the number of electrons in the reduction process, which is 5. So the reduction process now will give us MnO4 minus plus 5 electrons to give you Mn2 plus. Each of them multiply by 1, you have 1, 1, 1. Then the oxidation process, when you multiply by 5, you're going to multiply Fe2 plus by 5, Fe3 plus by 5, and E by 5. So you're going to have 5 Fe2 plus, giving you 5 Fe3 plus 5E. Now, next, we're going to balance the oxygen atom by what? Adding necessary number of water molecule. Now, on the left-hand side of the balance, ionic balance oxidation process of the reduction process, we have 4 atoms of oxygen. So to balance it, we'll add 4 molecules of water, so that we'll get 4 atoms of oxygen. Now, we'll add 4 molecules of water, we'll have an excess of 8 atoms of hydrogen. We'll balance it on the left-hand side by adding 8 atoms of hydrogen. Now, the 5 electrons in the reduction process will cancel out the 5 electrons in the oxidation process. Now, we'll combine the reactant side of both reduction and oxidation half process. So we're going to have MnO4 minus plus 8H plus 5 Fe2 plus to give you Mn2 plus 5E3 plus, which is the proton side, plus 4 molecules of water. And in that way, the equation, the redox reaction has been balanced. If it's the first time on this channel, School of Chemistry, and you find this content valuable, please click on the subscribe button before we continue. Now let's balance a more complex one, still in acidic medium. You know, acidic medium means hydrogen ion. Now first, we're going to find the oxidation number of element with variable oxidation state. Then secondly, we're going to balance the number of oxygen atom by adding necessary number of water molecule. So we have SO32 minus reacting with Cr2O72 minus to form SO42 minus plus Cr3 plus. Now in SO32 minus, the oxidation state or number of sulfur is plus 4. If you calculate it very like we have been doing, it's plus 4. The oxidation number of chromium is plus 6. The oxidation number of sulfur in SO4, that is the product side, is plus 6. While that of chromium ion is plus 3 on the product side. Now let's write the half equations. Now SO32 minus lost 2 electrons to form SO4 2 minus. That is from plus 4 to plus 6, they have lost 2 electrons, and there is an increase in oxidation number. So this process is going to be what? The oxidation process, and that is the oxidation half equation. Now chromium on the reactant side has plus 6 as oxidation number, and it has changed to plus 3 on the product side. That means it has gained 3 electrons. A decrease in oxidation number, that is decrease in oxidation number. It has gained 3 electrons, leading to a decrease in oxidation number. And this is going to be the reduction process. Remember, Increase in oxidation number is oxidation, while decrease in oxidation number is reduction. To balance the number of electrons, we are going to multiply the oxidation process by the number of electrons in the reduction process, and the reduction process by the number of electrons in the oxidation process. So multiply the oxidation by 3 and reduction by 2. So we're going to multiply SO32 minus by 3. I'm going to have 3SO2 minus, then 3SO42 minus, plus 6 electron. Because 2 electrons times 3 will be what? 6. Now CR2O72 minus, we'll not multiply there because we're going to have a case. Let's continue. Now when we multiply 3 electrons by 2, you have 3 electrons by 2. You are going to have 6 electrons. And chromium 3 by 2, we have 2 chromium. And this 2 chromium will balance the CR2 already in CR2O72 minus. So there's no need to multiply 2 CR2. Now let's combine the reactant side of both half equations and the product side. We're going to have 3SO3 plus 2 minus plus CR2O72 minus to give you 3SO42 minus. There was an omission here, that's why I'm adding it now. 3SO42 minus plus CR3 plus. Now let's calculate the number of oxygen on both sides. On the left hand side, we have 3 into 3 atoms of oxygen giving you 9 plus 7 in the chromate, that is 16. On the right hand side, we have 12 atoms of oxygen. The difference is 4 atoms of oxygen. So we're going to balance the whole process by adding what? 4 atoms of oxygen on the right hand side. So we're going to have 3SO32 minus plus CR2O72 minus, giving you 3SO42 minus plus CR3 plus. You see, I omitted the 3 plus, I'm adding it now, so don't figure that out. So we're going to have 3SO42 minus plus 3CR3 plus. Now, we are balancing by adding 4 water molecules to balance for the oxygen. So we're going to have 4H2O. But that has brought an excess of 8 atoms of hydrogen. We'll balance that by adding what? 8 hydrogen ions on the left hand side, and that was makes it an acidic medium. So when I add 4 atoms of hydrogen on the right hand side, I balance with 8 on the left. Please, if it's your first time here, before we continue, click on the subscribe button. If you find this valuable, like, share, leave your question as comment. Now let's balance a redox reaction in basic medium. First, we're still going to find the oxidation number of element with variable oxidation state, and then we'll balance the oxygen atom equally. So we'll have the manganate ion MnO4 minus plus iodide ion, that is I minus, to form MnO2 plus iodine molecule. The oxidation of manganese in MnO4 is plus 7, and it has changed to plus 4 at the product side, that is in MnO2. That means it has gained 3 electrons. That is going to be reduction, decrease in the oxidation number. Iodine minus 1 has changed to O on the right hand side. Minus 1 is less than 0. That is what? An increase in oxidation number. Let's write the half equation. The manganate ion MnO4 minus has gained 3 electrons because the oxidation number changed from what? Plus 7 to plus 4. That is reduction. Decrease in oxidation number. Has gained 3 electrons and is reduced to MnO2, where it has an oxidation of plus 4. And this is going to be the reduction half equation. The iodide ion with oxidation number of minus 1 has changed to oxidation number of 0. Minus 1 is less than 0. That means it is an increase. Increase in oxidation number is what? In oxidation number is oxidation. And that is going to be what? Our oxidation half equation. To balance, multiply the reduction process by the number of electrons in the oxidation process, and the oxidation process by the number of electrons in the reduction process. So multiply reduction by 2 and oxidation by what? 3. And that will give us 2 MnO4 minus plus 2 multiplied by 3 electrons will give you 6 electrons, and then 2 MnO O4. Remember, these two that we're using to multiply the number of electrons from the oxidation process. Now let's multiply the reduction process by the number of electrons from what? The oxidation process by the number of electrons from what? The reduction process, which is 3. So we're going to have 3 iodide ion, that is 3I minus, will give you, okay, we'll multiply from the left to right. So we're going to have 3 times 2 electrons, give you 6 electrons. 3 times iodine molecule, give you 3I2. But since there are 6 iodine molecule on the right, we'll balance it. So we're going to have 6 iodide molecule on the left. Let's combine the reactant side of both half equations. So we're going to have 2MnO4 plus 6I minus will give you 2MnO2 plus 3I2, because the electrons have cancelled out. Now on the left hand side, I have 8 atoms of oxygen, and on the right hand side I have 4 atoms of oxygen. So the difference in oxygen atom is what? 4. So I'm going to balance the oxygen by what? Adding 4 atoms of water molecule on the left hand side, because we are dealing with basic medium. So I balance with water molecule on the left hand side, and then because it will yield to an excess of hydrogen ions and still oxygen molecule, I balance the right hand side by what? 8 atoms of what? Hydroxide ion, and that will balance the equation as it is written: 8 atoms of hydroxide on the right, 4 water molecules on the left, and everything in this equation is now balanced. The OH minus is what makes it a basic medium. Welcome to School of Chemistry. If you find this valuable, do not forget to subscribe. Let me give you a classwork. Balance the radius equation. But before you do that, do not forget to subscribe to this channel. Balance the equation. Br minus plus MnO4 minus gives you BrO3 minus plus MnO2. Please subscribe, like, share, and comment. Leave your answer as a comment in the comment section. Thank you and welcome to School of Chemistry.